Afternoon, everyone. Again, I'm Chris McEntee, and I'm the CEO of the American Geophysical Union, and thank you for being with us and for attending this closing session, which I think is going to be really, really interesting. As I said yesterday, AGU and its members are committed to the practice and dissemination of really relevant and timely scientific research, and the communication of those results to the public and other stakeholders and our nation's policy leaders. And improving the intersection between science and policy is the key reason why we convened this inaugural Science Policy Conference. Over the past 2 days, we've engaged a variety of different stakeholders in critical conversations about the contributions that science can and does make, and why it's important to have that information to the well-being of our nation, as well as the role that scientific knowledge can play in shaping and informing really sound policy decisions that will protect our families, wisely utilize our natural resources, and work to build a foundation for a healthy economy. Looking into the future, the challenges we face as a nation are complex, although I think during the sessions here we've received some hope that they can be faced, addressed, and adequately solved. We looked at issues such as the supply of adequate sources of energy to meet the demands of our economy and our current way of life, addressing our food security issues in light of an ever-growing worldwide population, maintaining a clean and reliable fresh water supply that supports everything from manufacturing to basic human health, and protecting our families and livelihoods from the impact of both natural and man-made disasters. Addressing these issues will require coordinated solutions, and we hope by bringing together such a diverse group at this meeting of scientists, policymakers, and other leaders that we began to lay a foundation for further dialogue and for solution-based and informed decisions. I can think of no better way to close this conference than to hear about the history and example of Google Earth, a perfect example of how science can be successfully and beneficially integrated into the public discussion. This afternoon's speaker, Phil Keslin, who also accepted on behalf of Google Earth last evening an AGU Presidential Citation for Science and Society, is going to highlight for us the history of Google Earth, including examples of how the tool was being used. He will also offer insights on how innovation in science will and continue to benefit our communities, collaboration, and communications in the 21st century. Phil is the Chief Technology Officer of a small mobile application startup lab within Google. Don't ask him what it is. It's proprietary information that is exploring the convergence of mobile technology, geospatial information, and social networking. During his tenure with Google, he has also made contributions to Street View, Gmail, and Lively. In 2000, he was part of the formation of a new company called Keyhole, which I believe was 4 engineers. Is that what you said last night? While serving as their chief technology officer. How's one become the chief technology officer of a 4-engineer company? Phil led the development of an application called Earth Viewer that would later become Google Earth after Keyhole was acquired by Google.
So the topic that was presented to me was science and the 21st century economy. So what I decided to do instead was to use my experience with Google Earth and its predecessor, Earth Viewer, to talk a little bit about what people are doing with the product today and maybe extrapolate a little bit where I think people will go with it in the future based upon things that I'm seeing in the market today. So the first thing you're probably wondering is, you got a little bit of intro into my background. It's like, well, who is this guy, right? My background is not in GIS. Before starting Keyhole, I had no knowledge of geospatial information systems. My background was largely in remote sensing, mainly in the image processing part, and building visual simulators at Silicon Graphics. Earth Viewer itself started as a sort of feature demo within SGI in 1996 for their infinite reality graphics system. That demo was called Space to Your Face. It showed the globe. It was a very canned demo, primarily because we didn't have enough data to really show off the capabilities of the hardware. But what it showed off was the Earth spinning in the background, and you could zoom into Europe, hover around there, move a little bit, and then zoom into Italy, and then swoosh over to the Swiss Alps and focus in on the Matterhorn. And as you got closer and closer to the Matterhorn, you ended up at a Nintendo 64 that was sitting on a rock at the bottom of this crevasse. And that was sort of the start of EarthViewer. That was the vision of where we wanted to go. And I became involved in this during the development of a follow-up to that particular demo, when Mark Aubin, one of the other founders of Keyhole, and Chris Tanner, who was a founder of Intrinsic Graphics, the incubator for Keyhole, were working on the development of the next database for this demo. And they were having a really, really hard time chugging through these scripts. It was a really ad hoc process, and they had spent maybe 3 or 4 days just getting a couple of images in this database. And I rather jokingly said, oh, I could do that in an afternoon. And they both stopped, and they looked and said, well, why are you still standing here? About a week later, I worked probably like 12 to 14-hour days trying to get that thing to work, and it still didn't work. But the final outcome was a tool that would be used to generate the image databases for the next 3 years at SGI and for the first 2 years of Keyhole's existence. So I guess it wasn't in vain. And then I'll give you a little bit about little history. EarthViewer, like I said, started as a modest demo. It was sort of proof of concept for intrinsic graphics. That was in 1999. That formed the foundation for Keyhole, which was incubated inside of Intrinsic Graphics. We had 4 engineers and 1 executive and 1 PR person. We were crammed into 2 teeny tiny cubicles inside of Intrinsic Graphics. And in 1 year, we ended up building pretty much the basis for what you see today. Everything that's in there, the basic constructs, the streaming mechanisms, the technology has changed, but over the past 12 years, the basic foundation still exists today. And the vision that we had at the time of creating an highly interactive, very responsive, almost a fun interactive globe is still there. We had some problems along the way. The product really never took off. We originally wanted this product to be an advertising-supported product. We would give it away for free, and ads would enable us to grow the business. That never really happened. Even with the addition of KML in 2003, still didn't really accelerate the adoption of the product. It really wasn't until Google acquired the company in 2004 that the product started to grow. And my insight there is that the reason why the product grew was not because of the tool, but because of what went into it. And it's not just what went into it, but the technology surrounding the acquisition of imagery and geospatial information has been growing. It grew and has been growing at a really rapid pace. And just some of the imagery that you see in Google Earth today, only a small fraction of that was available when we started Keyhole. And I think if the data had been there and it was available, if we could have paid for it, then we probably would have been a lot more successful. So when coming up this talk, I was trying to think of basic topics to sort of ground me. And what I started with was the mission statement for the AGU. And that is, AGU galvanizes a community of Earth and space scientists that collaboratively advances and communicates science and its power to ensure a sustainable future. So the 2 pieces in there that really struck me were collaboration, collaboratively advances, collaboration for me, and communication. Those are 2 things that to me, Google Earth really exemplifies. And I'll start with collaboration. And to me, there are 3 types of collaborative activities. You can collaborate around a resource, whether it's a computer, a lab, the storage devices, a submarine. You can collaborate around the primary research or the data that you've collected. And finally, you can collaborate together on a particular research project, bring different insights to the outcome. Google Earth really is there to enable the first 2. Collaborating around a resource, I mean, the Google Compute clusters are capable of generating, it's a very massive collection of high-resolution imagery, and that imagery itself is the data that you were collaborating around. And I'll show you a couple of examples. Probably the most compelling for me is the one that really struck me was the work by Dr. Lee Berger in South Africa. And I don't know if you know about Dr. Berger. He's the individual who discovered Australopithecus sediba in South Africa. And the way he did it is the thing that really struck me. He is a paleoanthropologist at Witwatersrand University in Johannesburg, South Africa. He collaborated with others in 2007. He saw Google Earth and figured out that there was a way that he could plot existing locations where fossil remains had been found in the cradle of humanity just outside of Johannesburg. And he also knew of a collection of caves. And what he did was he plotted those caves and determined the geographical features that sort of made up those things and how to identify them in imagery. And then he used the high-resolution imagery available in Google Earth to plot out more sites, more potential locations where he could actually do this research. And if you've never seen what these caves look like, they're actually, it's more of a, it's not like the Grand Mammoth Cave, it's a pit, right? There's a hole in the ground and there's a cave underneath it. And that is where a lot of the findings had occurred in the past. And he, by looking at this imagery, he was able to identify those locations. And they went from about 130 caves and 20 known fossil deposits to almost 600 new sites to explore in one of the most explored regions in Africa. And it's not a very big area, so he was actually able to find quite a bit. And in August of 2008, his son, his dog, and a student set out on a hunch. And they went to one of these sites, and his son ran after his dog and stumbled upon a clavicle of a 2 million year old boy. I watched a video representation of this that was actually kind of funny. It was his son Matthew talking about the discovery, and his son said, I found something, I don't know what it is, but I found something. And Dad came over and he looked at it and he walked away and he was cursing in the background. And he was like, what's wrong? What did I do? And he's like, you didn't do anything. You just found one of our ancestors. So in the process of digging this up, they discovered the skeletal remains of about a 7 to 9 year old boy and a female that was very close by. There have been other findings in the area as well. The bones have been dated to between 1.97 and 1.98 million years. It is seen as the species, a bridge, a transitional species between Australopithecus africanus and Homo habilis, and it's quite possibly a direct ancestor to Homo erectus. So that was pretty significant. The thing that was amazing to me was that he did that. He made a large percentage of that discovery sitting at his desk. So that was this one. And there is they put together this little tour to kind of show off some of the sites, give you some idea of what's actually here. It's one of those things that you have to find it and explore it. But in this particular area, it shows the example of like, here's a fossil site. Well, it doesn't look like much from here, but that's because it's all completely underground. The reason why they were lucky enough to find these particular fossils is because the cave system had actually collapsed, which allowed them access to those bones. But there's a lot of other areas that are explorable in this area. So that was pretty cool. The other example of armchair archaeology is these tombs in Jeddah, Saudi Arabia. An individual by the name of Dr. David Kennedy, who is from the University of Western Australia, again, did a body of research he scanned a 1,200-kilometer area in Google Earth looking for potential sites. It's an area that has really not been explored in depth, clearly because nobody found these things. And what he found were a collection of pendant-shaped tombs in this area of Saudi Arabia. Dr. just as a footnote, Dr. Kennedy has never been to Saudi Arabia, so he had no notion of what he might see. But what he found in Google Earth is pretty surprising. He found almost over 1,000 of these in this 1,200 kilometer area. They are ancient tombs. There are hundreds of other sites, and all of these date back about 9,000 years. So again, he sat in his office in Western Australia and in Perth and found a wide collection of objects that are areas that they can do future research on. And before this, that would only have been possible by sending individuals into these areas and actually doing ground-based research, which is quite expensive, as you might guess. So from these studies, they're planning future expeditions now that they know exactly where to look, and that's where they're going to go from there. So the other thing that's pretty powerful about this tool and the imagery that is there is its ability to communicate. You communicating information about a place, especially when it's your home, is actually something that's really powerful. So probably most of you know about the Suri Tribe in the Amazon. They are an indigenous tribe from the Amazon region. They occupy a relatively small region in Rondonia, and so this tribe was largely isolated until 1969, when they were actually encountered white men, or the Westerners arrived to their village. They provided them with knives and pots and pans, and they eventually set up a dialogue and talked to them. Soon thereafter, disease struck their tribe. It took their numbers from about 5,000 individuals to about 290. Yeah, pretty devastating. Their chief, Almir, who is actually a college-educated individual, he's the first individual from their tribe who was college-educated, was in an internet cafe in 2007, and he saw Google Earth, and he saw it as a way to capture the cultural heritage of his tribe so that future generations would know about the things that were special about their tribe. This little tour that they put together, it'll play on its own. I'm not going to, we will turn on the audio, but so what he wanted to do was just draw a map, tell his people about the sacred sites, the places where they gathered medicinal plants, where his people lived, where their villages were at, so they could have that record for the future. What he ended up doing, what eventually ended up happening is this is the chief Almir right here. What he eventually ended up doing was capturing not just the culture of his tribe, the areas that were culturally significant, but he also managed to inform the rest of the world of the deforestation that was occurring in his homeland. You can see the area marked in white is their original area that they covered, and it is now shrunk to the region that is all green. Everything that is white is deforested. That has been completely clear-cut. You can actually see some trails in their area in this section here where individuals have come in and attempted to cut down the part of their forest. And for him, it's incredibly significant that they preserve as much of their home as they can. So he's working really hard to try and prevent future incursions into his territory. And the way he's doing it, back in 2009, there's a group in Google called Google Outreach, and their goal is to educate people about how to use Google Earth and to provide them with tools and technology in order to get their message out. And what they did was they went to the Suri Tribe, and they provided them with mobile GPS devices and cameras. And using that technology, they are able to photograph and identify the locations where these deforestation efforts are occurring, and report it to the authorities so that these people, now they have a visual record of these individuals who are actually cutting down these trees, which is illegal, and they can actually get these people thrown in jail. So that's one thing. The last thing that he's doing, which I think is really impressive, is he has started a reforestation project, and that his goal is to plant 100 million trees, saplings, over the next decade. And that to me is pretty outstanding. The next one is Appalachian Mountaintop removal. This is a group who feels very strongly about the Appalachians. They put together this tour, which is designed to explain the effects of mountaintop removal for extraction of coal. So they walk you through this whole process of what actually happens, how they remove the tops of the 400 to 500, 800 feet of mountaintops, where they put the waste, and what the waste does to the community around them. And that to me is a pretty powerful thing. I mean, I had seen these things before, but I really never understood what it was that was going on, or the impacts that it had on not just the visual part of the mountain, but the communities that surround it that are affected by the dumping of the overburden into the valleys and cutting off the streams nearby. So the last one I'm going to talk about is actually has less to do with Google Earth. It has a lot to do with an individual who I met at an Archive Live event in Mountain View. His name is Mike Fay. And I don't know if you guys know Mike Fay or know who he is. He is a National Geographic Explorer in Residence. He's responsible for the 1997 mega transect of Africa. He walked 2,000 miles from the Congo through Gabon, basically recording forested areas and capturing the human impact on these uninhabited places, not just the inhabited ones. His effort there led to the creation of 13 national parks in Gabon. He also did a mega flyover in 2004 of the entire African continent. He did something which is actually near and dear to my heart, which is a 2008 mega transect of the redwood forest from along the coastal California to Oregon regions. And since I'm from California and I love those trees, it's just amazing that he did something like that. And his last one, this most current one, is he's about to start on one that goes from Canada to Alaska. And his reason for doing this is he wants to give a voice to the human impacts on an incredibly pristine wilderness. And if you've never heard Mike Fay talk before, this is an individual who is incredibly passionate about saving these wilderness, these pristine areas. So the thing that was amazing about at least all of these individuals is that they given that little tidbit of information about things that are happening in the world around them, they're willing to go that extra mile to change things. In Mike Fay's case, he lives in Ketchikan, Alaska now. He saw a little tiny advertisement in the newspaper about this meeting that one of the northwestern British Columbia mining companies was going to, they were going to have a meeting in the town to discuss the potential impacts of this mine they were going to build outside of Ketchikan. And I can show you. It's a gold and copper mine, and it's at the headwaters of the Unuk River, which is the river that feeds into Ketchikan. And I don't know if any of you have been to Ketchikan. A large part of their economy comes from salmon fishing, and this has the potential of, in one accident, obliterating all of that. And it's understandable why he would be really passionate about that, why people in the community might be passionate about it. But the blurb in the newspaper didn't really tell you why they were having this meeting. And what Mike ended up doing was telling people what it was about. And instead of having 5 or 6 people show up for this meeting, had over 300 show up. And the mining company was so flustered that they left before the meeting was over. So to me, it's these people that are really passionate about these things. I heard earlier today in one of the in the National Ocean Policy, it's like it's getting things happening at the lower, it's the bottom up process, right? If you can inspire these people at the local level with the information that they need to understand what's going on in their communities, then they're going to take action and they're going to make sure things happen, or they'll find the right people to help them make those things happen. And Google Earth is one of those tools. It's amazing to see that people are actually using it to sort of reveal these things about their community. So in all of this, that there's one area that you probably notices that I'm missing, and that's the ocean, right? And that's because I haven't had enough time to actually do enough research to actually find out. The only thing that I really know right now is because of John Hankey's relationship with Sylvia Earle. I know about Mission Blue, but the amount of information that is in their layer, it's actually a part of Google Earth. That was one of the things that got added a couple years ago, was the ocean layer. They said, 2/3 of our planet is covered with water, but you couldn't actually see it. Well, now you can. But there's not much there. So there's a lot more in the coastal areas. So it'll be great to see what people do with the addition of the ocean layer and how they're able to communicate that with other people. So what are the trends? Well, so we've seen that I've shown kind of people using this tool for to collaborate, to understand, or to explore the world. There are individuals who are using it to communicate sort of their state of being, what's happening in their part of the world. Things that I'm working on right now. Well, we have a strong geospatial component, but everybody's got one of these in their pocket now, right? These are information providers. They're pervasive. It lets you ask the question whenever you have it, right? When 10 years ago, if you had a question, a burning question, you had to wait till you got back to your computer, and that may be hours. By the time you got there, I know I, for one, would have forgotten what that question was. But now it's always available. So if you have that question, you can ask it right now. The problem with the tools and the technology today, though, is you have to know what the question is. And in the future, with social networking, I believe that you can be inspired by others to know what questions to ask. And I think that's the direction that things are going to go in. You'll have a geospatial component so you can understand the world around you. You have mobile technology so you can ask the question. And you'll have social networking to help you know what questions to ask. And that's pretty much all I got to say.